And welcome back to the channel. We've got a very jam-packed video today. As you can see, we got a couple topics to cover. Ultimately, we're going to talk about these topics which revolve around how do you create a fully type-safe full stack application. So for example, imagine that we have a NestJS API on the back end and we have a React client. How do we maintain this type safety between these two guys? Well, we're going to achieve that by creating this centralized contract, which is going to act as the source of truth between what is the API, what routes are available, what is the shape of the responses, what are the status codes that are available. And both the backend and the React client has to adhere to that contract, and that's how we're going to achieve full end-to-end type safety. Now, finally, in order to be able to share this contract, we're going to put these together into a monorepo. And we're going to use turborepo for that. I'll show you the step-by-step instructions for this setup. So basically, we're going to have one repo with two applications and a centralized internal library, which is housing our contract. And then finally, I'm going to talk about how to create a basic CRUD API using this pattern, making sure that it's adhering to the contract. And then same thing using a type-safe client on the React side, which is going to utilize Tanstack Query, allowing us to manage all the data that's coming from the server side as we're interacting with this CRUD API. Real quick, I want to show you a quick preview of what is this we're talking about with end-to-end type safety. So we've got three files open here, all in the same repo. On the left side, we have our contract. This is a representation of our API. What are the possible paths? What HTTP methods can you use with that? And what is the shape of the body? What is the response body? What are the different HTTP status codes that will be returned? On the middle is our controller on the back end in a Nest API. This controller has to adhere to the contract on the left. So for example, in a contract, it says that we have a get one and it has to be able to respond with either a 200 or a 404 response. So if we take a look at the implementation real quick of get one on our API, you can see that it returns both a 404 and a 200. If we were to comment out the 404, you can see that this is actually going to get a red squiggly because it's basically informing us that, hey, you're missing something here. We were expecting to also get a return type of not just 200, status 200, but also status 404, right? So it's adhering to the contract. On the right side, we have a React client. You can see that it's using sort of a special version of React Query that is a type-safe client to the same contract that we're using. So you can see that it's just doing API client.todos.getAll. It's basically traveling through this contract, right? So todos.getAll. So that's ultimately doing a get, HTTP get on /todos, and it's getting back status 200 of an array of to-dos. And if we hover over the data, it already has that type, right? It has the status and it has this specific body, which is an array of ID, title, description that's coming from our to-do schema on the left, right? So the client doesn't need to know about, what specific HTTP method they need to use or what path they need to use. They just need to be aware of the path to the object in the contract. Right, so for example, if I rename get all here on the contract to just add a letter Z in the end there, you'll see that we start to see these red squigglies on the right side because it can't find that in the contract anymore, right? Same thing on the server side. It's saying that this is a mistake. Did you mean get all Z? Because that's what it's seeing in the contract should be implemented, not get all. Or similarly, if let's say we change the property on the schema, let's do title Z, I'll just add a letter to that. It's also ultimately going to give us a red squiggly on to do that title here because it doesn't recognize that from the response, right? So it's all tied together. That's what we mean with end-to-end type safety. Now, I think it's important to visualize what does it look like in the traditional sense if we didn't have this setup? What if we didn't have a monorepo? What if we didn't have a type-safe connection between these two applications? What would it look like? So first of all, I would imagine that, right, you probably would have these in separate repos. And let's imagine that, similarly on the backend side, we're defining some kind of controller a handler for, let's say, get to do's, and that returns a 200 with a shape and a 404 potentially with, a message. Now, without this concept of a centralized contract, how does our client side know about it? Well, pretty much you just have to basically duplicate the same thing, right? So you probably will have to manually type something like fetch/API/todos. And technically speaking, you have to manually check all possible status codes, right? You have to check for both 200, 404, and whatever possible number could be in here, right? Like, you really, from the client side, you have no idea what status codes that would return. Now, you can assume what that is based on maybe some kind of Swagger documentation, or perhaps you have the backend developers, or maybe you are a full stack developer and you're working on both of these, right? The problem is that there is no source of truth. So if, let's say, there are two different teams, and the backend developers, when they decides, I want to change this URL to /todos, right? They now have to communicate to the client side that, hey, you have to change this, or hope that they'll read your updated documentation, right? They now have to change that on the right side. Same thing, if they change the status code to, 201, and update the, kind of like what we showed earlier, if they update the schema of this, they have to do the same thing on the right side. And what does that typically look like? In most cases that I've seen, there's going to be a type representation of the response, or the DTO, on the left side, but also most cases that gets duplicated on the right side, right? Especially if these are in different repos, you don't have a choice, right? Because you're not going to magically get this type from somewhere, right? And the type is something that you need at the time that you're developing the code. So you can't just generate this at runtime. It's not really going to benefit you. So hopefully you kind of see the motivation behind what we're trying to achieve here, why it has to be ideally in a monorepo, why there has to be a central source of truth, so that we're not having to basically replicate the same thing in two sides, right? It's much more dry to have a single contract. And I think that ultimately it's just going to lead to a much better developer experience. All right, anyways, that's enough talking. Let's go ahead and jump into some code, and I'll show you how to set this up. All right, so I'm on my desktop with a terminal open. You can see I'm using Node 18, which comes with NPM 9. You do want to use one of the newer versions of NPM so that it has support for workspaces, which we need to make this work. First thing we're going to do is we're just going to create a folder. I'm going to call it fullstack mono. That's going to be our project folder. I'm also going to install a couple of things globally. I want to make sure to install the Nest CLI and also Turbo. And then I'm going to go ahead and just open this whole thing in VS Code. All right, so we're in VS Code now. We have an empty project. I'm actually also going to install Turbo as a dev dependency here, and I'll talk about why I installed it globally earlier as well. But doing that installation is going to give us a basic package.json, and I'm going to add two things in here: a workspaces config for apps and packages, and also some initial scripts that we're going to use for dev and build. So as you can imagine, that does mean we have to create directories for each of these. Let's go ahead and create apps. We'll also create packages, right? So apps is where our applications are going to go. That's where our Nest API and also our React client is going to live. Packages is for anything that is shared. Basically, think of it as all your internal libraries. On the terminal, let's go to apps. And we're going to use the Nest CLI that we installed globally earlier to create a new Nest application. So we're going to do Nest new API. All right, so that installed some dependencies. While we're still in the apps folder, we're also going to do npm create v@latest client. And that's going to create our React client. So make sure to pick React and TypeScript here. And then on the root, we do need to run npm install just to make sure all of our dependencies are installed across our applications. Next, at the root, we're going to create a turbo.json file. This is going to be the configuration for the tasks that we have in our monorepo. I'm going to add some code in here. You can see that we're defining a pipeline with two tasks. One is dev, one is build. So typically, when you run a task with turborepo, it will cache the result of that by default. So for example, if we run npm run build, you can see that it'll actually build both my client and API application, and it's also going to cache it. So every time I run this, it's just going to be super fast. So it's caching the result of these tasks. For dev specifically, we're not caching because we're running a live server, right, where the code is constantly going to be changing. So we don't want to have any caching on that. That's why we have cache false here. Now, just to walk you through, how did we make this build happen? Remember that in package.json, we have a script which runs turbo run build, right? So it's the same thing that if you have turbo installed globally, you could have just typed down turbo run build on the terminal as well. But on the root package.json, we just have these utility npm scripts that's using the internal local dev dependency turbo to run these. Now, what happens is basically when we say turbo run x, it's going to go into turbo.json. It's going to find that task that has the same name, which in this case is build. And then it's going to go through all of our applications, and it'll actually look through the npm scripts, and it's going to run the same script that has that name. So our API application has a build script. And if we open the package.json over a client, that also has a build script. So basically, it's just running the npm build across all of our applications. Now, as you saw, we also have dev. So that means that both of our applications should also have an npm dev script. On the client package.json, we already have that. We have a dev vite here. But on the API package.json, we do need to update the dev script here because theirs starts with start dev by default. So I'm going to rename that to just dev. Right, so just to recap, what that's going to allow us to do on the terminal is to run npm run dev, and that's actually going to spin up both our client and our API application together at the same time, and you can see the logs in the same terminal. All right, so now the next step in our process is to set up this contract. So we've already created our two applications. Now we have to create an internal package. And this is the part that I think could be a little bit confusing, so I'm going to go a little bit slower with explaining it. But in turborepo, the tool we've been using to manage our monorepo so far, they have this concept of internal packages. And this is really for anything that is shared across applications. So imagine that, for example, when you're installing packages from npm, right? npm becomes the repository, and you can install that, in any of your applications. We're going to do the same thing, except that our repository is within our monorepo. That's why we're calling it internal packages. So what is a package? Basically, imagine that, again, like you have an npm package, except it's local. So we're going to create a project within packages. Remember, that's another one of our workspaces. That's going to have a package.json. It's going to have some TypeScript code, some tsconfig that we'll talk about in a little bit. And then we're going to add it as a dependency to both of our applications. And then once we do that, we have to make sure to install from the root so that it kind of just links everything together. Now, the way it works is that you write your code in TypeScript. Now, what turborepo expects here is that you write your code in TypeScript, but then it expects your applications to transpile the dependency. So the dependency itself by default doesn't have its own, build transpile step. And in some applications, that's really easy to do. For example, in NestJS, next with an X, they have this option to automatically transpile dependencies that aren't already transpiled, right? So it's able to easily do that. You can see that for vite, it'll say that no configuration is needed. So it'll actually just kind of self-handle that. However, that's not going to work for our setup because of NestJS, and let me talk about that. So the thing with NestJS is that it doesn't have that same setting like it does in Next.js, where it can easily just transpile dependencies that wasn't already transpiled. So that basically means that we have to add that transpile step manually ourselves. So the contract, and then another thing with NestJS is that ESM won't work. So we actually have to transpile to common.js. So in order for this package to work in our Nest application here, it has to be transpiled manually and also needs to be in CommonJS. And that's going to add a little bit of a wrench in the setup here. And that's probably the main complexity of this setup, is just getting that correct. So I'll go ahead and walk you through how to set that up. So in our package directory, we're just going to add, let's call it API client. And we're going to add a package.json in there and also an index.ts. Both of them are empty right now. And actually, I'll put this inside an src folder. All right, in our package.json, I added a little bit of code here. So the main thing is make sure you have a name. In order to get the types working, you need to point types to a declaration file, and we'll generate that in a second here. And then we'll also need to point to what is the thing that we're exporting. So ultimately, we said that we have an index.ts. We will build that into a dist. It's going to be index.js after transpilation. We're going to be using tsrest for our contract, so that's why it's going to depend on tsrest core. And Zod is what we're going to use to define our schema. It's also going to be used for validations. And then just like with our applications, we also added a build step here and a dev script. That way, when we run dev, it's automatically going to transpile our code using tsc. And as we're changing the code, it's automatically going to watch for changes and automatically retranspile that into this JavaScript file, right? Also, we need to make sure to add a tsconfig in our packages, and this is what it's going to look like. I have some stuff commented out here just so you know what did I change from the original recommendation from turborepo. So you can see they have an example tsconfig here, and this is what you typically would use. But notice that I had to change module from ESNext to CommonJS because we said that's what we need. And also, you can't do the bundler module resolution bundler here if you're doing that. I also added output directory to be dist, root directory src, and then we need to add declaration true. This is what's going to create our .d.ts declaration files. So at this point, I want to make sure that our dependencies are installed. So back at the root of our entire project, I'm just going to run npm install. And you might be wondering, why didn't I do that directly in this directory, the API client? Well, the way that it works with workspaces is that you just install at the root actually, and it'll figure out what things need to be installed in each of these workspaces. So it kind of just determines it for you. And whenever you do need to install a specific package in a specific application, you can just use the -- workspace flag. So for example, you can do npm install -- workspace, and then the name of where you're trying to install. So in this case, apps/client, and then the name of the package as usual. As you can see here, we actually do need to install this rollup plugin CommonJS because again, from the documentation earlier, Vite is supposed to just automatically handle the TypeScript files, but because we're transpiling our code to CommonJS, we now need to update Vite configuration to use CommonJS as well. So we're going to install that, and we're going to open up our Vite config in the client, and we're going to add these two pieces of configuration. So the CommonJS here is the plugin we just installed. That just makes sure that at build time it is able to handle that CommonJS code. And we also add this optimized depths because I found that it runs into an error for similar reasons if we don't add it. Alright, so hopefully you're still with me here. At this point, we should be able to run npm run build in the terminal just to make sure that everything is set up correctly, and it should successfully build everything. Right, it should be able to build the contract, the API, and the client. Now, of course, our contract is empty right now, so we'll add some code there. Now, this just makes sure that our setup is correct. All right, so we have the setup. Now is the time to actually define our contract. All right, so the first step is to import this initializer init contract from tsrest and also z from Zod. We're going to initialize a contract. We'll just call that C for now. We're also going to create some kind of schema to represent our response object. So we're going to create a basic CRUD API for, imagine like a to-do list. So it's going to have ID, title, and description. It's also a good idea to export the type inferred from that schema so you can see z.infer is going to get us the actual TypeScript type that is equivalent to the same schema that we have here. All right, now we're going to initialize the actual contract from that C variable that we made earlier. So we're going to do C.router, and within here is where we actually define our contract, so all of our routes. So what you do is you pass in an object in here, and you can define whatever keys that you want. In this scenario, we're going to do a to-dos, and then within that, we're going to add the configuration that we want. So because we're doing a CRUD API, first we're going to do create. So that's going to define the post method, the path of /to-dos. To create, basically we want to pass in the same schema as we have here, but we're omitting the ID attribute because that's generated server side. And then typically in REST APIs, when you create something, you respond with a 201 with the full schema. So that's going to include the ID. Next, we're going to expose an API that allows us to get all of the to-dos that we have. So it's still on /to-dos, but it's an HTTP GET. If we wanted to, we can add optional query parameters such as title. Perhaps for searching, we're going to say that the response is going to be 200, and it's going to be an array of that to-do schema. We also want to have the ability to get one item at a time. So the difference here is we're adding a path parameter of ID. We can actually coerce that to be a number so that it's automatically a number when we extract it on the server side. Since remember that, because in the URL, typically it's coming in as a string. And then we have two different responses here, either a 200 when we actually can find that specific to-do item in our database, or 404 if we're not able to find it, and it's just going to have a message. So that completes our read. We're going to have an update, which is going to use patch method, same path. We're going to have the same coerced path params here. Now this request is going to have a to-do schema that is a partial. So that basically makes it so that either title or description is optional, right? So you can provide either one of those. And we're going to omit the ID because it's already up here in the path. We already have access to that. We don't really need that to be part of the body. The response is, again, the full schema of, basically after the updates. And that can also respond with a 404, same thing as what we have in the get one, because, there's a potential for the API to not find that given ID. And finally, to complete our CRUD, basically the same thing, but we're going to have method delete. Now in REST, technically it doesn't require a body. However, TS REST currently requires that we still define the body here. So we just need to pass in an empty object for this later. There is an open ticket that, there's people asking that we shouldn't have this, but for now we have to have that. And then for the response, we're going to do 204, which is for basically no response. We're just going to have, again, an empty object. Really, there shouldn't be anything in there, but again, it's requiring us to pass something at this time. And then 404, same thing if something that has that ID is not found. And then one last thing I'm going to add at the bottom here is some configuration for our entire contract. We're going to have a path prefix of /API. So basically every path in here technically will have a prefix of /API. So for example, /API/to-dos. And then we also pass in the strict status codes. That's going to allow us to have the most strict possible type safety when it comes to status codes with the responses. But basically it's going to enforce that only the numbers that we define in the responses here is allowed. The default of that is it actually allows any status code. All right, so that actually completes our contract. Now I'm going to show you how to have our API implement this contract. All right, so remember that our API client, this contract file that we have, is sort of acting like an internal NPM package, as I mentioned earlier. So our applications actually need to install it as a dependency. So in our API package.json, I'm actually going to add it to the list here as API contract star. And then while we're at it, we're actually going to do the same thing on the client side. So client package.json, make sure to add that as a dependency. And then the way that you wire these up together is at the root, make sure to just run npm install. Real quick, by the way, if we also run npm run build at the root of our project, again, it's going to build all of our applications plus our API contract package. You can see that it's running TSC here. So if we take a look at our packages directory, you should see a dist folder in there now, and it's going to have index.js, which is the common JS version of our contract, right? This is something that NestJS can actually use. And then we also have index.t.ts, which is the declaration file, which we're using for types. So at this point, we should be able to go into our API and actually create our controller for this todos API. So I'm actually going to use a little trick here. If we go to our app/API in the terminal, we can actually utilize our Nest CLI that, remember, we installed globally earlier to generate us some basic boilerplate. So we're going to do nest g resource todos, and we can just pick REST API here, but we're not going to generate the CRUD entry points. And that's just going to create us some files like the todos folder with its own todos controller, right? And it's automatically going to wire up that with a todos module, and that todos module is going to be automatically imported in our root app module. Hopefully this is familiar to you with NestJS, but I have a lot of Nest videos in my channel if this is completely new to you. But basically, it just allows us to get started very quickly. So what we're going to do is open up our todos controller, and this is where our actual implementation of the contract is going to live. Now, real quick, there's actually a dependency that I forgot to install. So back at the root, I'm going to install at our API workspace, we're going to install @tsrest nest, and that's just going to add sort of the actual integration between Nest and our contract made in TSRest. All right, so here's how we get started. First of all, we need to import our contract. You can see that we're pulling this in from API-contract. That is our internal package. You can see that all the types are wired up. We're also going to import tsrest handler from tsrest/nest, and also tsrest handler, a little bit confusing, but one is capital T, one is lowercase t, and you'll see what the difference is in a second here. But within our controller, we're going to create our handler. We're going to decorate that with tsrest handler capital, right? So the decorator is capital T. Within that, we're going to pass in contract.todos, right? So this is accessing the key in our contract. Remember, we have this parent key todos. And I forgot to mention this, but basically if you have, multiple controllers, right, you could create a new key in here to define another set of routes that would be implemented by another controller in Nest, right? So that's why that has a key like that, because the intention is you're probably going to create more. So on the handler, we just need to define which key are we trying to handle here. Next, the handler itself, the name of this function could be anything, by the way, but it has to return tsrest handler, and then we have to pass in contract.todos in here again, and then the actual implementation is going to end up within this object. Now, parts of this looks a little bit redundant, but that's just how we're supposed to do it with tsrest. And you can see that it has squigglies here because basically it's saying, hey, your contract is not fully implemented. If we actually try to see the quick fix here, add missing properties, you can see that it's going to add all of the missing functions that we have. It's going to say that it's expecting a return of the statuses. Remember, these are the things that it's coming from our contract. And then also the different arguments that each of these things have. For example, our create will have a body of title and description. Our get all has an optional title query parameter. Our get one can respond with either a 404 or a status 200. All right, so let's just run through each of these real quick, one at a time. So in our contract, we need to implement a get all, right? So it has to return a status 200. And you'll notice we're going to be utilizing the to-do service, which we haven't really implemented yet, but we'll do that in a second here. But let's just go through each one. we'll have a get all, a get one, and here that you can see that it's trying to find a to-do using the service, and if it doesn't find it, it's going to do 404. Otherwise, it's going to return 200 with the item. And by the way, we have all these red squigglies not because this is wrong, but because we haven't implemented the entire contract yet. But in a typical development, we're not actually doing it this way, right? Usually you'd probably update your contract, and then each update to the contract, you're going to update your API and also your client, right? So you're not typically just going to add everything like this, but I'm just doing it to kind of make it easier to explain. So we forgot to add the create, which is going to do to-do service.create and return a status of 201. We're going to have an update, which has a body. It's going to have the updates in it. Again, remember, this is going to have the type of just the title and the description without the ID. It's also going to have that same pattern of if it's not found, it's going to return 404. And just to finish up, we're going to have remove, which is, again, similar patterns. Use it to do service to remove something. If it wasn't actually found, we're going to do 404, 204 otherwise. Right, so that's pretty much our implementation. We just need to add the actual business logic underneath all of these pieces of logic. So for example, perhaps it's going to talk to a database to get these items. Now, before we get there, I need to actually remove this /todos, which is going to be a little bit counterintuitive if you're familiar with NestJS. We don't actually want to define the path anywhere, right? We're making it so that everything is in the control of the contract. It is the one that's going to define the path to /todos, not the controller itself. It's the same thing for why in the contract we have path prefix /API here. NestJS is not the one configuring that prefix. Typically in main.ts you would add something like app.setGlobalPrefix API, and TS-REST doesn't really work with that at the moment. And we don't even need to configure it right now because, again, the contract is already defining that, and this handler is basically already pulling in the information from the contract that it's going to be /API/todos, right? So we don't have to worry about it. Anyways, let's get to wrapping up our API implementation. We just need to fill in these methods within to-do service. So we go in here, to-do service. Now, if we had a little bit more time, I'd probably set up an actual database, but just to keep things simple and so that we can get through the video faster, we're just going to implement sort of a mock database here of an array of to-dos, and we're just going to manage this array. Basically, this is our internal database, and we can pull this to-do type from API contract. Remember, we were exporting that earlier. We infer that from the schema. So for our create, we're basically just going to create a new item. We'll generate an ID, and we'll push that into our array and return the new to-do. For our reads, we're going to add a get all and a get one. And for get all, we're just going to return basically the entire array, except if they pass in a title. Remember that our contract allows for this optional title query parameter, so that's why we pass in title here. If they do pass that in, we're just going to filter the array down to see if it matches that title somehow. Otherwise, return everything. And then the get one is really simple. It's just basically find by ID, return that specific matching to do. For the update, kind of similar, we're going to find the matching index of the to-do with the same ID. If it's -1, we return null. And this is so that we can handle the 404 in our controller. So you can see if there's no item here, it's going to do 404. Same thing, by the way, for the get one, because we did a find. So this will be undefined if it's not found. And then finally, to do the update, we basically just spread our old object plus the DTO, which includes optionally a title or the description. And once we're done with that, we're going to return the updated object. Finally, for deleting a to-do item, same pattern. We're going to find the index of it, return null if we can't find it, and then we're going to filter it out of the array if we did find it. And then, like I said earlier, technically we don't have to return anything, but TS-REST is forcing us there. So we're just going to return an empty object. All right, and I believe that's it. That's our implementation of the API using our contract, utilizing TS REST, now we should be able to switch over to the client side. All right, now we can implement the client side. So real quick, in the terminal, we need to install the integration between TS REST and Tanstack Query and Tanstack Query itself. So we're actually gonna do npm install /workspace app/client, and then we're gonna install TS REST /React Query and then Tanstack React Query. And what we're going to use that for is within src in our client. I'm actually going to create a new file. Call it API client.ts. And this is where we initialize basically a client that we can use across the application that already includes all this contract information. So you can see I'm importing the contract from our internal package, and we're initializing query client that is using that contract, and then just some base configuration. It's pretty much empty because we just need to provide some empty defaults there. And then before we get too far, we do need to make a quick update to our vite.config, and we're basically going to add a server configuration in here so that during local development, remember that we have the prefix of /API in our contract. We're going to say that every request to /API on our vite dev server is automatically going to be forwarded, proxied to localhost 3000, which is where our Nest API is running. So basically imagine that during local development, when we run npm run dev, our Nest API is being served up by Webpack, and our client application is being served up by Vite, right? So we have basically two dev servers that are running these. Okay, but anytime that we make a /API request on the client side, that's going to go to the Vite server. And we basically are saying, hey, Vite server, forward this over here to our Nest API that's running in localhost 3000. So I hope that makes sense. In the production version of this, we can make our React client be served up by the Nest server so that you only have one server in production. I actually covered that in my original turborepo video if you want to see what that looks like, but I'm not going to cover it here. But basically you just use NestJS serve static, and that can just serve up the client build, right? So that in production we build everything, right? And then you start up the server for the API, but that can also, in addition to serving up the API, it can also serve up the client itself, because we have a single page application. It can just do that. It doesn't need an extra server. All right, so now on our client side, to get started, for us to be able to actually use Tanstack Query across the application, we first need to initialize the query client provider. So in the main.tsx, which is the root of our entire application, we are going to import query client and query client provider, and then we're also going to initialize a query client. And then basically we just wrap our application with that using the provider, right? So query client provider, we pass in the query client in there, wrap our application. All right, so remember that, we have a CRUD API. So that means we have the ability technically to fetch data. We should be able to create a to-do. We should be able to update individual to-dos and also delete individual to-dos. So we need to set up some foundations to make that happen. So first, let's add a way for us to list out our list of to-dos. So perhaps let's create a new file, to-do/list. And this is going to house basically the component that is in charge of querying, get/to-dos to get our list. All right, so right now I just have an empty React component here. Let's start setting things up. So remember that we now have an API client. Let's import that. The props, I'm getting a little bit ahead here, but know that we have a list of to-do items. If we want to be able to select individual items so that we can call our /to-dos/ID, we want to add some kind of on-click handler to this. So anytime they click a specific to-do, we're going to do something. So in our props, we're just going to add on item click here. We're going to implement that later, but we just need to make sure that we are passing that in. Now here is where we start to see the usage of our API client. So if you've used React Query before, typically you would do something like this. You would bring in use query from Tanstack Query, and then you'd provide some kind of key, cache key, and then in here is where you provide some kind of function to, you know, make your actual API call. So it's something that maybe calls fetch or Axios. But in our case, this part does not exist because it's already handled by our API client. So what we're actually going to do is we're going to do API client dot to-dos, and then basically we're just walking through the object that we created in our contract. So remember, we have that parent key to-dos. Within that, there is a get all, and you can see some IntelliSense in here. That's part of the benefits of the type safety. Get all, and then we're just gonna do use query. So I'm just gonna merge these together actually. And the only thing we need to provide here is just the query key for the client cache. So if we hover over this data right now, you'll actually see that it has the type of from our contract status 200, and the body is an array of to-dos. And from Tanstack Query, you also know that it also gives you things like is loading. That's very useful. So what I think I'll do here is, if it's loading, we're just gonna show a loading message. And then on the actual return here, once the data is actually here, it's no longer loading. I'm just gonna create a list of to-dos. I added some basic CSS here, which it's gonna look ugly, by the way, so don't worry about how it looks. But we have a list. We're gonna display the title of each one, and then we're gonna allow the ability to click on any of these items, and when we click, we're gonna send the ID back up. So we're gonna actually manage that state on the parent. So if we go to app.tsx, there was some, you can see that originally had this boilerplate for a counter. We're just gonna, let's switch this up to some kind of active state tracker. So we're gonna track which to-do is open. Let's clean up this header and just add a to-dos header. We'll just add a basic div here, and then let's bring in our to-do list. Make sure to import that from /to-do list. And then we haven't implemented yet, but what we're gonna do is if there is an active item, we're gonna display a single to-do. Otherwise, we'll just show a message of click on item to view. All right, so our next thing to create is this to-do item. Let's go ahead and create a new file, to-do item.tsx. And then we're gonna go a little bit faster in this one, and I'll walk you through the code. So we've got a to-do item component. It's gonna take in an ID, right? Because we need to take in which one was selected. We also want to pass in this ability to change which one is active. So for example, maybe we want to be able to close what's open, because later on we know that we're gonna do updates. We have some values here, so just the ability to change title and description. And then same thing that you saw earlier, we're gonna set up API client to-dos that get one. We pass in a query key of to-dos in the ID here, and then the only difference is we need to pass in a param, right? So this is how you inform the API client which to-do we need to pass in. We just pass it in as a param, and it fills it in for remember /to-do/ID. That's where that ID goes. So that's gonna load in some data that has the shape of ID title description. And when that loads in, we're just gonna sync it up to our local use state here, which seems like a little bit of a weird pattern, but we're just doing a simple thing here because again, we wanna be able to allow the user to change the title and description later for our updates. Remember, we're doing create, read, update, delete, right? So same thing, that's why we have handle change here. We're gonna do set values as they type into input boxes when they change the title or the description. Similar pattern of if it's loading, we'll just show a message. And then the display, we just have basically an input box of the title and the description, right? So as they're typing into that input box, it's gonna manage the state for us. up here. And you're wondering why is it set up this way? It's really just to kind of speed things up a little bit for us. Typically what you might do is you would display the values statically, and then maybe you'll have some kind of pencil icon button to toggle between the view and the edit mode. I just simplified it so that it's immediately in the edit mode for us. So the only thing missing is the ability to save our changes. So this is actually a save button that we haven't implemented yet. So let's add save to do as a new component. So src new file save to do.tsx. Again, in the interest of time, I'm just walking you through the code that we need. So we're gonna render a button, and whenever they click that, it's gonna trigger something. And what is that something? We're gonna connect to our API client again, .todos.update, but the difference here is we're gonna use mutation because we're no longer querying, we're doing a mutation. And what that returns is, instead of an is loading, it has is pending. So whenever it's loading or is pending, we're just gonna disable the button so that they can't keep clicking on it. And then mutate is the function that you programmatically call to trigger your mutation. So basically, in this scenario, we are calling patch /to-do/id with the body. And where does that body come from? That's coming from the parent, which we said was being managed by our two input boxes here and here, right? So we're passing in basically everything it needs to make the request. The data wise, it's just being passed in from the parent. This is really just a button that triggers this request via our API client. And then if you're familiar with React Query, so remember that our application is wrapped in a query client. So basically anytime it fetches data, it caches that data. On success, we're just saying, hey, cache, go and refetch me the thing that has this key, because we have just changed it, right? So if we made changes to the data, we want to tell our cache, hey, something has changed, please fetch that data again. It just keeps our client in sync with our API backend. One last thing, we're gonna do delete -to-do.tsx. That's pretty much the same thing. It's gonna have a button. It's gonna disable if it's pending. It's also gonna be a mutation, but the only difference is it's just doing a different request, but ultimately the code is honestly exactly the same. One difference here is that it's using set active, so that if you have a to-do open and you delete that to-do, we should remove that from the screen, right? So we need to basically tell the UI to set active null. So that's why, if you were wondering, that's why we pass down set active to our to-do item here, so that it's being sent down to delete to-do. When you delete something, it informs all the way up to the parent that there should be nothing active. And it looks like we have some missing imports here. All right, so effectively we have the ability to display a list of to-dos, ability to display one to-do, and it's making those individual calls. We can make updates and we can make deletes. I think we forgot about our create. So the ability to insert a new to-do. Let's just do that really quick. New component, create to-do. And again, I've pre-filled the code for you here just in the interest of time, but let me walk through. Just like before, we need some state to basically track the inputs of title and description. Initially, they're just empty. And then, so you'll see in our JSX here, we have, just like in our to-do item, we have title and description. And basically, the user is just able to type in that whatever they want. But anyways, there is an add button, which is going to trigger handle submit, which again, remember that we have API client.todos.create .use mutation. So when we click the button and trigger mutate, it's going to pass in the values of our state, title and description, right? So this is ultimately going to trigger a post on /todos with a body of including title and description. And then similarly, on success of that request, all we're going to do is empty out our inputs, That way, we don't accidentally send the same thing. And again, we're gonna update our cache to basically refetch the list to get it updated. And I believe that completes our CRUD on the client side. Now we've written a ton of code. We haven't actually seen our application yet. All right, so on the terminal, let's run npm run dev. And you should see that our client is running on localhost 5173. Our API is running on localhost 3000. So let's go to this web page, and you should see something that looks like this. Yes, it looks very ugly. We didn't really write any CSS, but we have our list of to-dos that's being rendered by our to-do list. It's making a call to /to-dos with HTTP GET. If we click on any one of these, it's gonna load up our to-do item, and you can see that it is individually requesting its own data, even though technically we already have it, but it's making a call to get /id, and then we should be able to update this, hit save, and you can see that immediately it's updated over here. That's why all of the state management is managed by Tanstack React Query. Again, remember, when we save here, it's going to update the cache. It's going to say, hey, cache, refetch me this data because it just changed. That's how it's ultimately managing the data for us. I can also hit delete here, and now we just have B and C. And then actually, real quick, we forgot to add our create. So in our app.tsx, let's just drop that in there. It's going to look really ugly, but we're going to import create to do. And now you should see this really ugly create form here. For example, perhaps you have a to-do list to subscribe, and you can see that it added to the list. We can also open that same thing, save it, delete. Could change this to like, save. Again, you can see that it's working, and you can inspect the network here if you want. So for example, if I delete this, you should see a request to delete that ID, 204, no content, right? And as we click around, you should see that it's making the necessary calls to our API. But again, remember, with all this type safety and contract stuff, our client has never had to manually, type in these paths like /to-dos, or it didn't need to manually define the types for the responses and such like that. One thing we didn't cover is validation. So, if we should have added like some kind of validation to this input form, but because our contract is written in Zod, TS_REST will actually automatically validate that object. So you could set up your schema in such a way that it also adds constraints, like it shouldn't allow numbers or something like that. But that's getting a little bit too much in terms of scope. So that's it, really. That's it. This is the end of the video. Hopefully you've stuck around to see the end result. I know, not very pretty, but I think the developer experience of having end-to-end type safety is the important aspect here. Again, just being able to share types. The setup was a little bit complicated, but I think especially if you need to use Nest in your backend, it's really going to open up your options in developing that API versus if you just used something like NestJS. It's going to be pretty limited in my opinion. But anyways, yeah, thanks for sticking around. Hopefully you got something out of this video, seeing all these things put together. Let me know what you think in the comments, and hopefully I'll see you in the next video. Thanks for watching.